This is Siren with Startup.Security, and welcome to another lesson. In this lesson, we're basically going to be going over a couple of things related to Metasploitable too. In the past, we've talked a lot about reference file enumeration systems, all kinds of great stuff. And we've learned about bash scripts and discovering machines, just a plethora of things. Bash aliases, all that good stuff. Now it's time to start attacking the machine. So what we're going to do is we're going to export the IP equal to 192.168.1.23. That's for me. It's going to be different for you on your machine. And we're going to do a -A scan. So let's just get some practice. We do nmap -p-. That's 65,535 ports, -A at the target IP, --open, --min rate equal to 2,000, because we're not so concerned with being detected. And let's go ahead and hit the return key, and we'll let that scan go. We're going to give an aggressive scan on this, and then we're going to take whatever scan we get back here, and which is basically going to be this output, and we're going to move it into a note. In this note, we've called it primary enumeration, and we've used our template. I've just copied and pasted the template into here, and we're going to put it under our Nmap results section. So I'm going to bold this out because that is what we are going to be going into while this scan completes. This is one of those pen testers with their feet up type of moments. This is where we're doing our scan, and there's not really much else that we can do. Maybe Minesweeper or something like that. You know what I mean? There's not really too much else. We're doing active reconnaissance on the target machine. What do I mean by active reconnaissance? Active reconnaissance means we're throwing packets at it, but it's not payloads. It's not weaponized code. It's just reconnaissance information or reconnaissance packets to gather information about the target machine. And we can hit the return key here and check the status. It's about 99.67% done. And yeah, then we'll go ahead and get that on over into Cherry Tree. And what we're going to do is kind of discuss some lowest hanging fruit. I'm going to start by the lowest port number, but you're more than welcome to attack this machine from whichever port or service that you want. I encourage that you follow along. I very much encourage that you follow along with me. Because I have a lot of really core points to be made in these lessons. But in your own time, you're free to attack any of these open ports in any of these services on this machine that you like. That's the cool thing about it. It's always there for you. You don't need a subscription, and you can always practice your methodologies, your enumeration, your scripts. So we're just going to copy all this output. Let's just copy all the output, all of it, scrolling up, and boom, right up through Nmap scan report. And we'll hit copy. I'm going to Alt-Tab into Cherry Tree, and let's paste it in. Great. So now we've got all of our Nmap output for the target Metasploitable 2 machine. What I like to do at this point is start highlighting ports. So I've already got my red color selected. Shift-Alt-F, and then Enter. And that highlights this. So instead of our eyes not being able to quickly see what is considered lowest hanging fruit or open ports or services while scrolling through tons of output, it is a useful habit to get into to just highlight the ports and highlight the services and highlight versions. Beyond that, you'll probably find yourself wanting to highlight even more verbose information down the line. but this is stuff that can be done with the keyboard, and you get pretty quick at it. It doesn't take but a minute or two, and it helps kind of with determining, which, not just which ports are open, and which services are there, but what the lowest, again, what that lowest hanging fruit is. So that's what we're going to go through, and we're going to highlight everything here. Great. So now that that's done, now that this is done, we're going to go ahead and highlight the service. We have FTP. I can double click. SSH, Telnet on 23, SMTP, mail on 25, domain on 53, and 80 HTTP, 111 RPC bind, and then here's our 139445 NetBIOS SSN, 512 exec, 513 login, 514 seems to be a TCP wrapped kind of thing, but that's okay. 1099 bind shell, and let's just go through and make sure this is really clean. See how already things are starting to stand out? This is the kind of thing I want you to, get into the habit of. I'll do this once, and then next time when I say, have your highlighted output, I'll just skip ahead. I'll pause the video, and I'll do my own highlighting, and then we can resume. But I want you to see the types of things that I'm doing it, and why I'm doing it, what my method of thought is, like a weak HTTP port here. We have DRB, which is Ruby DRB, RMI, Inlock Manager, status, Java RMI. These are all the types of things we would punch into Google, right? And we would want to Google, and we'd want to see. That's the service. Then we can start highlighting the version information or what was given out. Remember, what are we looking for? We're looking for the target OS, right? Well, I found a way to find that over here. We have Ubuntu. Target OS is Ubuntu. Boom. Nice. So I'll go up here and I'll put Ubuntu. So we already got the target operating system from this Nmap output alone. Our IP, I'm going to put the IP of our target in here, .1.23. And this would be the IP of the machine that's in scope during your engagement. It's a useful template like that. But in this particular scenario, we're going to be going over some of the lowest hanging fruit. So up here, we have port 21. Port 21 is FTP, and we have vsftpd, or vsftp daemon, 2.3.4. So, well, that was my bad there, my mistake. Shift Alt F, enter, 2.3.4 of vsftpd. So that one there is pretty low hanging fruit. Why? Can you spot it? Anonymous FTP login is allowed. That's not cool. That alone is pretty low hanging fruit. By the way, I'm going to save my stuff. Got to put my money where my mouth is there. Always save your notes, guys. Always save your notes. Just in the event that it crashes or whatever it is, always keep things saved. So, what is an anonymous login? It's actually quite simple. This is one of the easiest and quickest things you'll ever check in penetration testing. And we can do it super easy with this methodology. FTP at the target IP. Then, all we have to do is punch in the username of anonymous and the password of anonymous. And that's it. We get code 230, login successful. Remote system type is Unix, using binary mode to transfer files. We can type ls to list out files in the directory, or dir, or we can do ls-a, And notice how we get back more information with ls-a. If you ever find an FTP Anonymous access finding, make sure you do ls-a. I've seen so many, even CTF machines that, man, they'll get you. They'll get you on this, because if people get in, they'll find their anonymous finding list and they'll type dir and there's nothing there, ls, nothing there, but they didn't know they could do ls-a, and they'll find hidden files. So always remember to ls-a. But that is not particularly the finding in and of itself. So per FTP protocol, what we'll do is we'll just type bye, and it'll say 221 goodbye. Unfortunately, there's not really much there. So what we're going to do is I'm going to open Firefox, and we're going to check out some stuff. So I've got this open here, and I'm going to move Cherry Tree over here, maximize it, and then minimize it. And we've got Firefox open. What we're going to do is Alt-Tab to our enumeration, right? Our file. We're going to copy this version information, and we're going to go to Google up here at the top. We're going to paste this in, and we're going to search for vsftpd 2.3.4 exploit. And we're going to get back a lot of results. Rapid7, the exploit database itself, which is awesome. Seems that there's a backdoor command execution. Sounds nice. Let's check it out. Okay. So here we are with a piece of weaponized code or a verified exploit. And it seems to do some imports, signal, SIGINT handler, takes some arguments, but what's the real thing that it's doing? Where's the payload? Well, there's another way to connect to FTP. And before I demonstrate what this payload is doing, I want to show you. Remember that anonymous login thing? Let's try that another way. Instead of using the client, the respective client, which we would usually want to use, we're going to do something a little bit different. So yeah, this other way involves Netcat. So we're going to use Netcat to the target IP, and we have to specify the port this time. That's 21. And we got a banner grab back, 220 vsftpd. This is essentially what the -sv argument, by the way, from Nmap is doing. It's a banner grab. But in this particular case, we're just going to do this totally raw. We're going to use the FTP protocol and say user anonymous pass anonymous, and it says login successful. Isn't that cool? Pretty cool, pretty cool. Now, what we're going to do is Control-C to cancel out of this. And we're going to take a look back at this kind of side by side. In fact, I'm going to highlight this part here and then bring this up. So let's look at this backdoor. You know, what's the purpose of a backdoor? Pretty much whether you're in hacking or you're not in hacking, the good news is, even if you're just coming out of IT or you're coming out of computer science in college and academia, you probably know what a backdoor is. You've probably heard about it all the time. It allows a hacker to be able to access a system, and it usually goes unnoticed, right? In our world, if we're going to examine it from a more technical perspective, a backdoor is going to allow us to execute code or execute commands, system-level commands, on a target machine that is in our scope. And usually to access the backdoor, well, it depends. Maybe it's a web backdoor. Maybe it's something here, for example. Or like something that can be accessed from a URL. Or maybe it's something that's accessed, in this case, from the username. So In fact, there's one other thing that I wanted to show. I really do want to nail this point home. vsftpd 2.3.4. Let's go to nvd.nist.gov and let's see what they have to say about it. All right, looking around, description. vsftpd 2.3.4 downloaded between, this date and this date contains a backdoor which opens a shell on port 6200. My oh my. So whatever is going on in here, we should expect a backdoor bind server. Remember how we made one earlier with Netcat-NLVP and we set up a bind server on port 9090 and then we connected to it on 9090? This is exactly, literally the same thing that is happening. There's no difference. It's creating a bind server, except this time it's doing it on port 6200 and executing bin bash. So now when I connect to it and I type, if I can get the port correct, the target machine is essentially doing this. I'm just replicating it locally. Now if I type ID, nice, I've got a shell. Very cool, huh? Because upon connect to port 6200 on our Netcat server, we've executed bin bash. This is exactly the same type of thing that this vsftpd backdoor is doing in the malicious code. There was an unknown actor who snuck malicious code into this vsftpd backdoor, or vsftpd server, or the source code of it. And if you supply a smiley face, I'm going to zoom in on this. But if you supply a smiley face, we'll call this the smiley face backdoor, or the smiley face emoji, in the username field, then it starts a server. You guessed it, it does this. It starts a listening server. In fact, you could really just put like that. Listen on port 6200, right? But it's going to do that and execute bin bash or bin sh upon supplying that smiley face. So we can trigger this ourselves. We don't even need this payload. We can do this manually. And I encourage you every step of the way to do these things manually. It's as simple as that. Because the more that you do something manually and hands-on, the better you're going to be as a penetration tester down the line. The more effective. So I see something real quick from the start. I see this in our Nmap output. I Google that plus exploit. I see that we've got something on the exploit database. This could take me a few seconds, but that comes with time and experience. I see a smiley face provided here. I've cross-referenced that with CVE details or NIST.gov, and I'm just looking at the actual CVE 2011 2523. I've done some scrubbing, opens a backdoor on port 6200. Okay, let's say this is a CTF. I know exactly what to do now. I'm going to netcat net verbose to the target IP on port 21. I'm going to supply a user of, we'll say siren with a smiley face and a pass of no pass is required, I think. And that's that. Now what we're going to do is netcat net verbose to the target IP 192.168.1.23 on port 6200 and type ID, and we now have root over the target machine. That's correct. We now have root on the target machine. So that was that back door, and we didn't need a single piece of code. We did this just through analyzing the code. I can't tell you how important it is to analyze the payload. analyze the piece of weaponized code, take it apart with the scalpel, and really, really look at it. Because if you do, not only are you learning about what these other hackers are doing and how they're thinking, but at the same time, you're learning coding. And at the same time, more importantly, you're zeroing in on the actual thing. And it's not all this other stuff. Everything else would not work. I want to emphasize that. None of this code, and none of this code would even work if this smiley face was not here. That is the level of detail and granularity that we need to be approaching when we're doing our CTFs, or in the real world when we're in an engagement. That's just that level of granularity that we need. So we've got a root shell on the target machine. Nice. And we can verify that with who am I, root. We can cd to the root file system directory, ls-lsaht. This basically says list all in a human readable format and sorted by time as well. And I can bring that in. And there we go. That's the root FS of the target machine. We now have totally owned this machine. That's, good game, right? It's over. The level of integrity of this machine, the integrity from this machine has completely dropped. It's been compromised. It is game over. And we have exploited that backdoor. I'm going to type exit to drop the shell, and that'll drop our Netcat connection as well. I'm going to go here just for reference. I'm going to copy the URL that led to the payload that led to the command execution. And for our reference, I'm going to put that in here. That's it. So if we ever want to come back to it and exploit it the same way again, we can just click this link and open it from Cherry Tree, and we're good to go. But with that being said, we're pretty much ready to move on to another backdoor. And this one has to do with UnrealIRCd. So this next backdoor is the UnrealIRCd, or UnrealIRCdaemon backdoor. And unlike the vsftpd or vsftpdaemon backdoor, we don't have a version supplied up here. Oh no. We don't have a version. But if we looked at the script output, we would notice that Unreal 3.2.8.1 is supplied, and the version information is supplied. Let's definitely go ahead and highlight that. Awesome. So what I'm going to do is I'm going to copy this, and you guessed it, we're going to go back here, and we're going to search for Unreal, add a space, 3.2.8.1 exploit. And looking around, we have Rapid7, Tenable, we have GitHub, and it looks like we have an exact version match for UnrealIRCd. And looking through it, I'm going to go back to the exploit database and take a look and see what we got here. Zoom out. And this one's a little bit longer. It's about the same size. This one is written in Ruby. So with the payload that's written in Ruby, it's really not that much different than Python. It is very similar, and it reads a lot like English. So looking through all of this, we have our description, right? This is definitely something that's meant to be used in the Metasploit framework. So what we're going to do is launch msfconsole, and we're just going to let that load up. And I bet you if we search for it, it should appear in there. So if we just search Unreal, we have Unreal Tournament 2004 secure. Apparently there was an overflow for that, Unreal Tournament. And then there's an UnrealIRCd 3281 backdoor. with a rank of excellent. Nice. So what we can do is type use, and then we can copy this whole thing, Control-Shift-C, Control-Shift-V, and do it that way. Another quick trick to be even faster is you see the number sign over here. If we found the exploit we want to use, we can type use 5. Done. Then we can clear the screen, type options, set our hosts. So let's say we want to set our remote hosts. We set our hosts to 192.168.1.23. Or another little trick inside Metasploit is, like, let's say we go to another one. In fact, I'm going to do this intentionally. I'm going to go back and you don't have to do this. You can just watch and search Unreal. And let's say I wanted to use the exploit for the video game Unreal Tournament 2004. And let's say I go to use that one instead. Well, if I type options, you'll notice that our host is not set, even though we set it for the previous payload. There's a trick for this. So if we go back and clear the screen, search Unreal, and I'm going to use 5 that corresponds to the exploit Unix IRC UnrealIRCd 3281 backdoor. And I'm going to set G. That's short for set global. Our hosts 192.168.1.23. Now, anytime that I'm playing around in Metasploit and I want to throw a payload around to a target machine, I don't have to keep supplying that variable or setting that variable. It just set it globally. So a little nifty trick there to save you some time when going through payloads and so on and so forth. Though we do try to be as accurate as we can. So we have the port already supplied, required, yes. Remote host, required, yes. Exploit target type is automatic. What I want to do is type show payloads. What type of payloads can we get on this machine? I want to use, for the purposes of demonstration, we could get a reverse shell, reverse bash, reverse Perl SSL. We could establish, similar to that backdoor, we could establish a bind shell on the target machine, but I just want to execute my own command here. And this is just for the sake of learning. So I'm going to say set payload, not global on this one, but set payload, and in double quotes, payload CMD Unix generic. What does that mean? Well, let's type info, or we can clear it and type options. And I'm going to bring this down for legibility. But notice how we still have the same information up here, but now we have an additional section, our payload. We want to be able to specify our payload. Payload options CMD Unix generic. Now, I want to specify that although we're going over Metasploitable 2 and we're using Metasploit, if you're taking like one of those offensive security type certifications or just proactive security certifications, Metasploit might not always be available, which is exactly, and I mean exactly, why I'm going to teach you a methodology here. Remember, we're here to learn Siren's methodology. So let's say we have command execution on the target machine. We already know Metasploitable 2 is vulnerable. Like, dude, we already know that. I'm going to sudo switch user, and we're going to need to be root for this, but I'm going to type tcpdump-i, any interface, and kind of like the grep command, we're going to grep for incoming ICMP packets. Why am I doing this? Because I want a non-destructive way of verifying that I have code execution over the target machine. So I'm going to set the CMD equal to, in double quotes, ping with counts of 3 ICMP packets, 192.168.1.233. And that's us. That's our attacking machine. So we're saying target machine, ping us, ping the attacking Kali Linux machine. And we'll type run. Now if we run this, great, awesome. We have just gotten back a ping, which means 3 in fact, and that verifies that we have command execution on the target machine. Nice. So we could supplement that with a reverse shell. We could supplement that CMD with whatever we want. But you know how I like to do things. So what we're going to do is Control C out of this. We're going to clear this. And one thing when I was going through my learning phases that helped me tremendously was visualization. So I'm going to hit the command key and open up Wireshark. Go ahead and open Wireshark on your end. And then I'm just going to listen on any interface. And it's already recording, which is great. I'm going to hit run on this, just literally going to type run. And here, I can, not to confuse you, I'm actually going to leave this. We're not even going to listen for anything. We're just going to analyze the payload. And there it is. It's being sent along, so on and so forth. It's done. And I'm going to hit the stop recording button. And then what we're going to do is right click in here and follow TCP stream. Cool. So just like from our previous lessons, we right click, go to follow and TCP stream. Now what's the actual payload? Let's pull up the payload here. Here's the remote code execution, the RCE. Here's the exploitation of this backdoor. But it says there's a backdoor. This is not an overflow. This is not, a command injection or code injection. This is a backdoor. Me being the curious ethical hacker or white hat hacker that I am, I'm like, dude, where was that backdoor? Sure, we exploited it in Metasploit, but we don't want to be a scrub. We want to be really, really good at what we're doing. Where was that backdoor? So sock.put AB, capital A, capital B, and a semicolon. That's all it was. That is literally all it was. Let's look at that and let's verify that in our packet capture. So similar to Netcat connecting, we have a connect, looking up your host name, couldn't resolve your host name, and then AB ping -C 3.192.168.1.233. Well, let's try this with Telnet. I'm going to go down here to one of my other terminals, and I'm going to Telnet. In fact, I'm going to export the IP down here as well to be 192.168.1.23. And then I'm going to Telnet to the target IP on port 6667. Cool. Now I'm going to type AB and then semicolon ping -C 3.192.168.1.233, our attacking machine. I'm going to switch user to root in another terminal and do the same TCP dump trick that I had before to verify code execution or verify command execution. TCP dump -I any and then ICMP. We're looking for ICMP packets. Oh, I wasn't quick enough. Let's clear out of this. Telnet to the target IP on 6667, and then we're going to say AB colon ping -C 3.192.168.1.233, and there we have it. Look at that. See, we didn't need to even use our Metasploit card at all. We were able to identify exactly what was going on. We identified where the backdoor was, where the magic was really happening in this bit of weaponized code. Did any of this mean anything? No. That was just set up for one line, more specifically, one piece of one concatenated string in a sock.put. Pretty cool, huh? So that's the UnrealIRCd backdoor. It was just the letter A, the letter B, a semicolon, and then payload encoded, and some new line. We hit the return key. And we were able to get back packets. Now we could get back a shell if we so wanted. In fact, I kind of want to do that. I'd like to demonstrate to you the difference between, reverse shells. there are a couple of things here when talking about reverse shells. In fact, I'm going to exit out of Metasploit here and sudo switch user and export that IP equal to 192.168.1.23. I just get in the habit of doing it, you know, when I open terminals. And what I'm going to do is use Telnet and target IP on port 23. And this time I'm going to use a bash alias that I have called revshells, or reverse shells for short. And you'll notice I have little parentheses up here. This is a TCP socket, TCP socket, TCP socket. What is a Netcat? What is this? What is it? What is the difference? What is going on here? We have IO redirection. So that there are two different types, even if it's using the Python language or the PHP programming language or the Bash scripting language or PowerShell or Perl. Those are usually raw TCP sockets that get created and connections that get established, output that gets executed, and that output gets piped to, over the socket, over the connection, to an attacking IP, which is us. That's the one most people would know and be aware of. But here's a little difference that most people won't talk about. And this is why, this is a second point that I want to nail and bring home with the UnrealIRCd backdoor. There's more to be learned here. So we already know how to execute code. We just telnet to the target IP, the port. We supply AB semicolon and execute whatever freaking command that we want. It is that simple. It is that simple. Okay? But what if we want a reverse shell? Let's set up our own Netcat listener, just listening on port 9090. I'm going to copy this whole thing here and use a poor man's text editor. That's just a £. Replace the IP address 192.168.1.233 on port 9090. Then I'm going to copy this. And if you don't have this resource, it should be supplied to you, maybe even in a cleaner version through the Learn platform. In fact, I'm going to be making an effort to make sure that you guys have all of these. If not, you can visit sirensecurity.io and you might find it there. Either way, or you can use Pentest Monkey if you don't find it on my blog. If it's not there for any reason, then you can use Pentest Monkey or just Google reverse shells. There's a bunch of websites for reverse shells, but here I have a condensed notation to show you. So this is a TCP socket one, right? We're going to telnet to the target IP. Oops, not on 23. No, not the Metasploit machine. Excuse me, on port 6667 on the IRC port. And we're going to, not the telnet port. And then we're going to put in that there. And now we're going to punch in the backdoor AB semicolon. And we should be able to paste this in and get a reverse shell when we hit the return key, right? Ooh, the suspense is killing me. If I hit the return key, oh no, we didn't get a shell back. But I thought it executed any command. Well, in the world of backdoors, sometimes, and I just mean sometimes, it isn't a TCP socket that needs to be created. Sometimes we need to do a little bit of input-output redirection. And that can be done and achieved with either something like Telnet. And by the way, you can hit, to exit Telnet, you can hit left control and then right square bracket and type quit. Or you could use something like Netcat for IO redirection. So watch this. We know that a TCP socket reverse shell is not going to work for us. But are we going to give up? No way. We're smarter than that. We're also going to try an IO redirection reverse shell. So we're going to copy this. The Netcat one right here. and paste it in, replace the IP, copy it, again, paste it as AB semicolon here, and look at that. We've got a reverse shell. ID. We can type ID. And it may be a little bit slow, but we've definitely gotten code execution. We're much further along. I may have done it too slowly. In fact, I want to try this again. But we're going to Control C out of this. But I'm going to Control C out of that. We're going to quit out of this. And I'm going to try this again. Except this time a little bit quicker. You know what? I've got a better idea. You see, if I have to take you guys down a path of failure to show you or teach you multiple lessons so that you don't go down the same rabbit holes, you know, that I have gone down, then that's the way I prefer to do it. So yeah, this did get us kind of a shell. It executed it, right? And we got a shell out of it. But let's say that a bash TCP socket reverse shell is not working. Let's say that a Netcat IO redirection is not working. What is another thing that we can do? We can make a bind server. We already know from the ping command and ping output, if we look at our Wireshark here, that we had 3 ping ICMP packets come back. We know that we have clean code execution. Let's use Netcat on the target machine to create and drop down and create a bind server, and we'll say for it to listen on 9997. By the way, you don't need to telnet to the target IP on port 6667. We can even use Netcat here to target to to connect to the target machine on port 6667, and this will work just fine. So let's say Netcat net verbose to the target IP 6667, and we'll connect, and there we go. Then let's execute our backdoor here, AB semicolon, and we'll specify what's known as an absolute path, /bin /nc for Netcat, and then we'll say -nlvp net listen verbose on 9997, and upon connect, execute bin bash. Now what we'll do is Netcat net verbose to 192.168.1.23, the target machine, on port 9997, and we should have a shell waiting for us. If we type ID, we do. Now we have a shell. And if we really wanted to, if I was being quick with things, I would use Python. I type TTY, it's not a TTY, and we'll go over this later. I would use Python to break out, spawn a TTY, still not a TTY, which Python? That didn't work. Maybe Python 3 is not present. You see? And then we use Python -c import pty.spawn, and boom. We now have a shell that is not invisible on the target machine, a bash shell. So Python -c, and then in single ticks here, import pty.spawn bin bash. Now if we type tty, we've got one, dev pts1, and we've got a root shell on the target machine through that back door. And did we have to use a Metasploit payload at all? No, we did not. And do we understand the backdoor? Yes. And do we also additionally understand what we do? No, we got to keep trying. We got to keep trying as hard as we can. We got to keep going, right? So if we type revshells here for my reverse shells, then, you know, we know a TCP socket reverse shell did not work with that backdoor. And we got a little more success with IO redirection, but it wasn't stable. We would get something like this, we'd execute ID, and it wouldn't execute. It would drop the connection. Well, We had to get more clever than that. And we have command execution on the machine. Certainly there's a way. We used this. For an absolute path, make sure it's an absolute path here. It might not be in the environment variables, right? Upon code execution. So /bin /netcat nlvp, listen verbosely on port 9997, and execute bin bash. And now the UnrealIRCd, if we go back here, the UnrealIRCd service on port 6667 has not only been exploited successfully, but let's put down here, well, let's add some lessons learned. Let's add some lessons learned from this, right? What are some takeaways thus far? And we're going to have a lot of these from the Metasploit machine. And just imagine how many takeaways we get when we get into a massive range. Let's see how many takeaways we have here. One, use the proper client for the server. If the server is hosting FTP, connect with FTP. However, in the event of a backdoor, we're talking about a lot of backdoors here. What else do we want to look at? We also want to analyze the code. We also want to analyze the code very rigorously to identify the culprit, so to speak. In the event, in the case of our FTP backdoor, it was a smiley face emoji that opened a bind server shell on port 6200. We were able to exploit that with a simple Netcat connection. Additionally, what's another thing that we took away? We have UnrealIRCd in that backdoor. Always, when learning about how a payload works or an exploit, analyze locally. That usually means off of the loopback adapter 127.0.0.1, right? And analyze the traffic. Right click, follow TCP stream. That's another thing that we learned. Right click, follow TCP stream. Excellent. What's another thing that we've taken away from this? Well, in the case of the UnrealIRCd, so in the case of UnrealIRCd backdoor, we had AB and then some command to execute. If at first a reverse shell via TCP does not work, what do we try? That means we try a reverse shell via IO redirection. Did that not work? Are we going to give up? No! Try a bind server. /bin netcat dash listen verbosely, you could say on 9090 or 9997 or 1337, and execute bin bash. That worked. So there's some takeaway, right? And let's go here to port 6667 and say that, well, we'll know what this means. AB semicolon /bin /nc /bin /netcat dash nlvp on 999. So which one port did we use? Yeah, 9997. And dash execute bin bash. And we'll highlight this. and our steps to reproduce if possible, right? So one, we did netcat netverbose to 192.168.1.233 on 6667, right? Because that's the vulnerable service. And then we have our little backdoor here. I'll highlight that in orange. AB, and then the command that we executed, which was our bind server, and I'll put that as 2. And then 3, what did we do to connect to that? We said netcat netverbose to 192.168.1.233 on port 9997. We typed ID, and we got root. Those weren't really steps, this was just commands executed. ID, and we got root. In fact, I think that's up here. Yep, let's get that exact output and put that in our notes. It's a good habit to take down the steps per service that you had. In fact, that's going in the takeaway. It's always a good habit to get into, to take down the steps the steps that led to successful exploitation of the target machine. In a formal report, this is known as the steps to reproduce section of a finding. So definitely something to know there. When you're writing your reports for a client or a stakeholder, or even for one of your certifications, let it be known that you really should supply a steps to reproduce section followed by screenshot evidence. But that's that. We've exploited the port 21 backdoor, and we've even supplied the source here, the actual source code of the payload itself, and broken it down. And that again was just netcat netverbose to, you'll see the pattern emerging here. .168.1.20 on port 21. And then we said user, some user, smiley face, pass, some password, and then what did we do? We netcat netverbose in a separate terminal back to it on port 6200 and shell received. And I will highlight this in orange because that was the backdoor or the sensitive object in that particular case. And there's our steps to reproduce for both 21 and 6667. Now we're ready to move on to port 80. So with regards to port 80, if you know me, you know that I'm a web specialist. Let's go ahead and open up Burpsuite. First things first. I do have Burpsuite Professional, but I'm going to stick with you. We're going to use Burpsuite Community. I'm going to prove that it can be done with Burpsuite Community as well. And we'll just click Next and start Burp. Now yours might come in white. It might be bright white. I'll show you how I change that. What you do is you go to Settings, and then you go to User Interface, Inspector, and Message Editor, and just scroll down. HTTP message display, font monospaced. Make sure it's always monospaced so that things are cleanly spaced out, like a command terminal. And change font. You can set it to 16 like I have. And then you can go to Display, set it to dark. I can set it to light. I can set it to dark. Sorry for that bright flash there, but there it is, dark. And font size 16 there as well. And we can close out of this. And then what we're going to do is go to the Proxy tab, and we're going to use Burpsuite's built-in web browser. I'm going to hit Open Browser. Go to Cancel, 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 and it should open up Chromium. Nice. So what we're going to do is go to 192.168.1.23, and we can specify port 80 with a colon and 80. Oh, hello. Metasploitable 2. Warning, never expose this virtual machine to an untrusted network. Contact msfdev@metasploit.com. Log in with msfadmin to get started. Let's say we want to exploit TWiki. Let's take a look at TWiki. And more specifically, let's look at the getting started. So this is some kind of old wiki web application. It's very old. And honestly, I'm looking around and I'm not seeing any versioning information. What's something that we can do if we don't see versioning information, but we see a date? We got to think outside the box here. What we can do is we can scour the internet for versions that correspond to the date that this, like, see copyright 1999 through 2003. That means it was back in the early 2000s. So that doesn't give us a version, but when looking for our versioning information, we can at least think outside the box and say, well, if there were any payloads back in 2003, 2004, 2005, 2006, 7, or 8, they might just work. So let's do that. What we're going to do is type in TWiki Exploit. And let's see if we get anything. Making sure intercept is off. It is off inside of Burpsuite. Rapid 7, some Tenable stuff. TWiki themselves talking about a command execution that used to exist. And the exploit database. You know me, I'm going straight to the exploit database. And let's take a look. So again, another, given that this is called Metasploitable, go figure, you can pretty much exploit everything from msfconsole or the Metasploit framework. But I want to take you, it's the process that counts in these lessons here with us at Startup.Security. It's the process, it's the methodology, right? Because not everything in the real world is going to have Metasploit. It's identifying the root of the attack, the core concept or idea behind the attack in the code. It's about doing it manually, if possible, right? So in this particular case, we have a lot of obfuscation. It doesn't really stand out too much. We see that there's some get. That makes sense. It's a get method for a web service. You know, it could be get, it could be post. Usually get or post data are involved in exploits. And, you know, we have a search parameter here, view main web search. We have a URI that's given to us. Well, the cool thing is we're doing studying. So what are we going to do? Let's do this. I am going to Control-C out of our thing here. We're going to clear every screen. I'm going to exit out of our shells. You can type exit twice there. And the point is we're going to just clear out of everything, get rid of any shells, and we're good to go. Let's launch msfconsole, and we'll do that down here. And I'll close this one out, and we'll just let it rock. Now, once this is open, what are we going to search for? We're going to search for TWiki. Search TWiki. And oh my goodness, we have a lot to choose from. But we don't have versioning information. Unfortunate. However, like I mentioned, we do have a date. This was a CVE released in 2004. And if we look, we have a copyright for this version on the web back in 2003. Some payloads don't always exist. Like if there's a vulnerable version of a web application, a 0-day may be there, but no one might know about it. People might not know about that vulnerability in a service or an operating system for years to come. Pseudo-edit is a great example. There are many great examples of that. A plethora, a tremendous amount. So I'm going to put that in my takeaway notes immediately. I'm going to go down here and I'm going to say, look, if we don't have version information, we can at least cross-compare the date or year information with any weaponized code or exploits that were released in that era. Let's say plus 5 years or so for leniency, give or take, right? So if we go back here, we have through 1999 through 2003, and then we go to Metasploit here, and we've got 2012, 2014, and then lo and behold, we have 2005 with the TWiki search, or excuse me, TWiki history, and then we have TWiki search down here in 2004. Okay, let's try using the TWiki search one. So we'll say use for. Set options. We're going to set the R hosts to our target machine. You know the drill. 192.168.1.23. And let's look around. L host is already set here. That was with the set G, or set global, 192.168.1.233. And listening port is 4444. We can set an advanced option. You can always show advanced. And many of these you can use, they have verbose set to false. I encourage to get in the habit of setting verbose to true. So we've set verbose to true. We can clear this out, type options, and looks good. Now before we run this, I'm going to go over to Wireshark, and I'm actually going to close out of the previous packet capture. Let's do a clean packet capture here. We'll remove any filters. We're going to start a new one, and it's recording. Everything is great. Fantastic. So what we'll do in this particular case is just type run. It's going to say started a reverse TCP handler, successfully sent the exploit request. It's going to say exploit completed, but no session was created. So in this case, even Metasploit, even the Metasploit module that's pretty much supposed to work for this isn't working. We're hackers. We got to get more creative than that. Something failed. We got to keep trying. Let's analyze the payload itself. Let's see. Here's a GET request to TWiki bin view main web search. I'm going to stop recording. I'm going to go up here, right click, follow TCP stream. And here we are. So we have a whole bunch of gargly glick here. It looks like this is supposed to be the reverse shell. But where is the entry point? I'm going to copy all of this and go over to Burpsuite. So again, we're copying everything from /get all the way through HTTP 1.4/1.1. And we're going to go into Burpsuite, and we're going to go to decoder. I'm going to paste it in, decode it as URL. And there we have it, TWiki bin. Now it's very legible. So it looks like to me, if we're really taking a close gander at this, we have a reverse shell that Metasploit wanted to send along that was very complex and very involved. Let's see if we can simplify that with a command of our own. We're going to type show payloads, and we're going to make a generic, payload generic custom. So we're going to set payload to payload generic custom. I'm going to type options, and actually instead that wants it from a file. Let's say CMD. That would be a payload specific from a file. Where are you? Aha. Is this what we need? Yes, generic command execution. So payload CMD Unix generic. And I'm going to set payload CMD Unix generic. Options. And we have CMD equals blank. I'm going to set CMD equal to just the ID command. As clean as can be. Let's go back. Let's close out of our packet capture here window. Let's close out of all of this and restart our recording. No packets captured. We'll listen on any interface. So again, we've just restarted listening in Wireshark, and we're going to type run. ID successfully sent exploit request. And it should go through at least. Did it not? Maybe it didn't. Let's see what happened. What went wrong there? So I paused and then resumed. Honestly, there was nothing particularly wrong with it at all. We just had to send it a few times. Let's type run. It may not go through and be captured properly. Who knows? This could boil down to the way the payload was written. Let's see. We didn't get what we needed there. Let's type run again. Until we're looking for HTTP requests. That's ultimately what we're looking for here. Nothing there. Let's type run again. Until we get what we're looking for, which is a whole bunch of green output and basically, oh, turns out all I had to do was click in the filter thing and click return because there was still that filter applied. That's why it wasn't working. Make sure to clear your filters. But yeah, follow TCP stream. So here we are. This is a lot more simple for me. This is a lot more of a simple payload for me to analyze. I'm going to copy this. I'm going to bring this over here. And we're going to decode as, let's say, URL. Or decode as base64, not base64, decode as URL. And it looks to me like we have, what is that, command injection? I think so. So we have some string that's supplied, some random string, and then an apostrophe, colon, ID, apostrophe, and a pound sign. This was our CMD right here. Make no mistake, this was CMD. This is what we set. Remember when we said set CMD equal to ID? Well, that's the string. That's the command. That's the payload. So if we can theoretically open this in a web browser, we should be able to get some command execution and see what's going on. Let's do that. You know, why wait? Let's open up a web browser. I'm going to copy that URL. Let's make sure we get it in full. TWiki, bin, view, main, web search, all the way up through the vulnerable parameter. I'm going to copy that with Control-C. And from the web root, paste it in. And we'll say search for Startup.Security. I don't know. We'll say search for that. And we don't get anything back, but it looks like, you know, we're in the right area. So let's say in this case we'll supply ZZZ, just some bogus string, and then single apostrophe, and let's make sure it matches. Single apostrophe, semicolon, ID, semicolon, there's that second semicolon, and then pound sign, and single apostrophe. And if we send that along, nothing really works. That's unfortunate. It didn't really work the way that we thought it was going to work. Maybe this one just isn't vulnerable. Maybe it is, maybe it isn't. Do we want to give up? No, not yet. Let's try another variant. We have TWiki search, right? But let's go back. Let's type options, and we can just quickly, we can search for TWiki. And let's try the history one. We'll say use to. Options. And the bin, we'll set our host to 192.168.1.233. It only takes a minute. Show payloads. And let's set this to, as before, our debugging one. So we want to set this to payload CMD Unix generic. Clear this out. Set payload equal to, in double quotes, or excuse me, set payload equal to this, and then set CMD in double quotes equal to ID. Let's try the history version, the one from like a year prior. And what we're going to do is do the same process. We're going to clear out of this. We're going to restart the recording process in Wireshark for our packet capture. And we'll type set verbose true and run. Let's take a look. Let's take a look. Let's take a look. Did we get anything here? Maybe we have to hit the return key up here again. Nope, we didn't get anything. Unfortunate. Where's our GET requests? Let's look at options. CMD is set to ID. Our host is set to... that's what happens. Set our host to 192.168.1.23. And we'll type run. And sure enough, here's our same old, same old. This time, it's exploiting what looks to be like a rev parameter. So my point is, the previous exploit didn't work. That's the takeaway from this. The previous exploit didn't work, and we don't have a version. So we have to kind of meander around the one that might work. Let's right-click this, follow TCP stream. We're going to copy everything from the /get, or get / rather, and copy that and bring that all the way over into, you guessed it, decoder. We'll paste it in, and this one's a little bit different. Look at that. Isn't that cool? This one isn't a single, can you see that? It isn't a single apostrophe. This one is a backtick. So what really was it vulnerable to? Well, let's test it. Let's find out. We'll open this up side by side, and is it TWiki, bin, view, main, and then we have TWiki users. So let's copy all this, the unencoded version, paste it up here, and I can clean this up. We'll make this like ZZZ, and it looks like nothing really happened there. What if we make it a number as it was? And then pull this up. Do we see any command execution? Nope. No command execution there. What if we just set it to something that's valid, like 7? Boom. It's worth it to keep trying. It really is. So with a little bit of extra trying, a little bit of extra due diligence, analyzing the payload, taking a look at the board and seeing what's in front of us through our packet capture, we really were able to analyze exactly what it was that the TWiki exploit, which if we search for it on the exploit database, through the rev parameter, if we put that in quotes, and here we are. It's right here. Actually, they have this version. It says CGI bin view main TWiki users rev, and then so on and so forth. Additionally, if you don't want to use Burpsuite, I use MayorWeb. I just type MayorWeb encode decode. You know, it's like if I'm in a terminal, I don't like to leave the terminal. If I'm in a web browser, sometimes I don't like to leave the web browser. So I'll paste that in, decode, and then here it is. That decodes to 2 pipe less etc password. So maybe we could have used a pipe parameter or pipe here as well. There's a bigger point that I would like to make from all of this. And yes, we have command execution on the machine. Yes, we can type PS and receive a process list back. Yes, we can type ls on / and receive back everything from the root file system. Yes, we can do that and see what users are on the machine, ls / home, and see the users present, right? But at the end of the day, or at least get some semblance of code execution, my goodness. At the end of the day, what if there was another way to do this? This was a backtick. What is this? What type of attack? Always, and this is going straight to the takeaway, it really is. When considering, or rather, when analyzing weaponized code or exploits, if we really have to look closely for what attack type or attack vector is being utilized. Back in the day of the early 2000s, they just called it command execution. Nowadays, we refer to this as command injection. This is a command injection, and you will find plenty of machines as we go forward that might be vulnerable to command injection. Command injection can come in a variety of forms. The principle is this. In the backend code for command injection, and maybe I can put this under 80 up here respectively, but let's say 80, and then with regards to TWiki, look at how we had all of this stuff. My goodness, imagine if you were a beginner and you'd come back and you were just using Metasploitable and you had searched for TWiki and you see all of these things here: arbitrary command execution, remote command execution, parameter command execution, and not a single one of these, not even one, is telling you the actual attack type. The actual attack is known as a command injection. This is incredibly important information, and it is pertinent to your success as a penetration tester. Here, we were able to supply, and we're going to take this apart, the vulnerable parameter. We injected a command, a system-level command. This was command injection. That means we injected a system-level command into what? A vulnerable web parameter. Let's just say a vulnerable parameter. It doesn't always have to be through the web. How does command injection arise? How do we usually get command injection? Where does command injection usually come from? The answer is simple. Concatenized, and I really have to check my spelling on this, but concatenization. I apologize for having to check my spelling on this one. Concatenation, excuse me. But it comes through in concatenation. The answer's simple. Concatenation of user input into a system-level executive statement. What does that look like in something like PHP? It's relatively straightforward. In PHP, we might say, like this. This is a vulnerable code snippet. In PHP, we might say system execute ID. That's not vulnerable. That just executes ID. When this bit of code comes along, it's just going to execute the system level command ID. But, what if what parameter did we have here? A rev parameter? That's a get parameter. What if we concatenate $_get rev? Yikes. That would be command injection. Because now it's ID plus, basically, if you want to imagine a plus sign there, plus whatever we supply in the URL parameter. And this is known as, again, command injection. So I'm going to take this away. Where does command injection usually come from? The answer is simple. Concatenation of user input. That's that rev, that's the input that we supply to the rev parameter in the value of the rev parameter in the URL address bar or in the GET request, right? Into a system level executive statement. And that's how command injection occurs. And that, back then, if we had a time machine and could go back, we'd bonk them on the head with a stick and say, no, this isn't just remote code execution or a remote or RCE or a code execution. Sometimes I even see it, or command execution, I even see it mislabeled as a code execution. That's different. That would be code injection. And we'll talk about that later on as well. But this is a command injection attack. It's important to know that because there are a plethora of ways to work with command injection. In this case, we're able to execute, let's keep it simple, ID. And we get back that we're web data, www data, right here, or GID, right here, is equal, our group ID is equal to 33, which is www data, right? Very cool. Very cool, very cool. So what we'll do is kind of, let's look at, the other version, right? The other version of it that we found on the exploit database that had dealt with, and I think we left that in Firefox. And this was a pipe. Well, with command injection, it's simple. Look, I can execute ID, and that'll say I'm root. This is the best demonstration of command injection I can give. So imagine that a service executed, like we'd said, system and then ID, right? That would be the equivalent of executing ID and getting back this. What if I say ID and then chain a command? So once ID is done executing, chain that, we're going to say semicolon, chain that into, I don't know, who am I? Now, when ID is done executing, it'll chain that into the who am I command. And we can do this as much as we want. We can even say, let's say, I don't know, let's say echo hello. See, now we've executed 3 inline statements and chained them together. The principle here is that this command line should be thought as kind of like the URL address bar in this particular case. If we pull it up side by side, we have 7 and then our command injection here, ID. What happens if we put ID in backticks? Well, it does give us UID is equal to root and then command not found. Interesting. But we were able to get a command to execute. At least get the output of the first portion up through a space. What if we say, and I want to take you through this. I really do. Let's say that how many ways can we execute a command off the command line landmine? Well, it turns out there's a lot, dude. There are a lot. What if we have that input, right? Something fails and then we say ID. Well, 7 UID is equal to 0 root, but we still got the command to execute. What if we say 7 or 77 and then pipe that to ID? Now this is going to say, essentially, well, 777, that failed. And therefore pipe that output, or this is, in Unix, it's saying pipe the output of 777, which is going to fail to ID. The ID command, right? Command not found. Well, we can be even more clever than that. We can intentionally fail. We can say ZZZZZZ, and then we can pipe that to ID. See? Same principle applies. We can also do that with double pipes. And this is known as an intentional fail, but these are all command injection examples, or examples of how we can use operators, but we can use operators there to achieve the same results. So what about if they're block listing that? What if I can't type ID? Is there a way around that? What if I need to do something more advanced, like ZZZ pipe to I and then do a block listed strings bypass? Notice how we still got ID to execute. I $, open close parentheses D. This is command injection. This is much more advanced, but that's what we're here for, right? So it's like we know command injection exists, but it's hard. It's being difficult on us. Make sure you try a block listed strings bypass. Make sure you try the same thing with a /i/d. Look, root still executed. And that's because both this $ open close parentheses and a backslash off of a command line result to what's known as a null statement. Or they come back as null. They're null statements. So, and here we can get fancy. We can say, let's see if that pipe worked. Let's say, can I put in the letter Z ID and get any form of command execution? Let's search for www. Doesn't look like it. So it does need at least a number. It needs, in the back-end code, we can infer that from this black box perspective, we don't have access to the source code at all, that it needs a numerical provided. So what if we provide 1? Hey, that worked. Pretty cool, right? So we're onto something there. We know it needs at least a number. And this is that black box penetration testing kind of stuff that, I love so much through the web. We can infer that that's what's going on in the back end in the code. It's looking for a valid number. The letter Z will not work. Anything A through Z will not work. So we need to supply something there. And then what if we try to supply something like too many ones? Do we get, nope, doesn't seem that works either. We don't get any output. What if we pipe that instead to ID? Still does not work? Okay. What if we double pipe it to ID? Still not working. Okay, what if we double pipe it to ID and terminate the statement with a $? Well, that's not working either. What if we remove all of these ones, go back to a valid one? So we've tried both two cases, valid input and invalid input. Remember that. And now, lo and behold, we have ID invalid option --k. Try ID --help for more information. So look here, we have our, one pipe ID. We're definitely getting somewhere with command injection. We're getting somewhere. What about a single pipe? We're getting that -k as well. So something programmatically in the background is breaking our command. We're not getting ID to execute as we would like it, but it is technically kind of executing because it's showing us that it executed improperly, like something between ID or something like that. So we can try command injection with a pipe. We can try command injection with a backtick. What about backtick ID? That didn't work. What if we wrap the ID in backticks? That works. And that is really the core of the exploit. So it's really iterating through command injection. And I encourage you to Google command injection examples and do some extra research on command injection to kind of identify the various ways in which command injection can occur. In fact, we're going to be taking apart DVWA, or Damn Vulnerable Web App, and we're going to be going through a plethora of ways in which command injection can occur. This is taking quite a long time to load, but you get the point. You'd want to Google that there. Can we chain statements together? Can I say backtick ID, backtick, who am I? Nope, that's going to break it. So then we have backtick ID and then the semicolon here. What if we supply a pipe to who am I? Well, that worked. We got www data back. So the point is you can mix and match. You can play with these things. Let's bring it down to its simplest example as was provided in the payload that we analyzed, by the way, in Wireshark. Just again, right click, follow, TCP stream. we brought this over, it provided some numerical integer, which now we know why it wasn't working. Because this is not a valid integer for it to work in the application. It needed to be one of those posts on the wiki that, or one of those numerics on the wiki that would have corresponded to a post, rather. And 79,722, I don't think there's that many wiki posts. So it failed, and that code did not execute on the back end. But I hope that makes sense. And we'll be going over command injection even further. It's time for us to go ahead and get a shell. I'm going to use the bind shell method, and what we're going to say is bin netcat -l on port, let's say port, I don't know, 9997 -execute bin bash. And what this is going to do is open up a Netcat bind server on 9997 and then when we connect to it, it's going to execute bin bash. So our command injection here starts here with that backtick, goes through, we close it again with a backtick, and then a £sign. Notice how that £sign is very similar to an ending statement off of the command line. Like we're closing everything after that. Very cool. So what we'll do is we'll exit out of this and we'll type netcat net verbose. We'll have our command ready to 192.168.1.23, the target machine. And let's actually do this the full proper way. Echo IP, that's our target IP. Netcat net verbose to the target IP, and you'll get so quick and fluid with this. On port 9997, and let's open up that. Let's go ahead and open up that bind server. We'll hit the return key. It's spinning. Let's connect to it. It says connection refused. Oh no! Are we going to give up? Is it the end of days? Is it all over? No. We're going to find out what went wrong, and we're going to try and get a shell on the machine. Maybe instead of specifying, maybe it was the forward slashes. Maybe there's some type of sanitization happening on the back end that doesn't like the forward slashes. Like if I were to go here and the rev parameter and type /, maybe it doesn't like that. Maybe if I put like one /, yeah, comes back as undefined. Like maybe there's some checks that happen programmatically that, you know, the back end strips away our ability to take away or to use forward slashes. Are we going to give up? No. Instead of that, we're just going to type netcat -nlvp on port 9997, then -execute bin bash. And now let's try. It's spinning, and we'll connect to it, and the port is open. We've connected, and a connection has been established, and if I type ID, there we are. We have a shell as www data. That's successful compromise of the remote machine. We've played around a lot with command injection, and one of our takeaway statements here is, you know the type of the attack. Know the type of attack. If you want to think like me and you want to think like Siren, know the type of the attack. KNOW. Understand what that is. That means do your research. Go here. Look up command injection examples. Search around on Google. And if it's not working in there, we'll try it here in Firefox. Command injection examples. And you see OWASP up here, Imperva, Port Swigger. What is OS command injection? How to prevent it? And you can read through this, and you'll see the ampersand applied here. There are different ways. For sure. Like, what if we wanted to supply an ampersand? The problem with an ampersand up here is that the ampersand is going to be interpreted as a get parameter. It's going to be, the backend web server might interpret this ampersand as something expecting like and parameter equals value. Yikes. that means our command injection wouldn't work. But I can show that as well. So here we are. We have our shell. We can cd to /. We have the root file system, ifconfig or IPA. If ifconfig doesn't work, IP /A. And, you know, we have it here cruising on .23. So we'll hit exit. And everything is looking really, really good. We've taken apart a lot of things related to this particular TWiki vulnerability on port 80 for the Metasploitable 2 machine. And let's try one more thing to prove our point here. In fact, this time we're going to intercept it in Burpsuite. We'll go to proxy, we'll turn on intercept, and this time we'll type in ID and we'll send it along and intercept it in Burpsuite. Close out of this. Very nice. We can see things legibly. We'll send that to repeater, which is kind of like the Swiss Army knife of Burpsuite. If they say Netcat is the Swiss Army knife of hacking, make no mistake, repeater is the Swiss Army knife of web attacks. No joke. It is the repeater tab. So we can send this along, and we should see our www data. There it is. www data. So command injection worked properly. Awesome. That's awesome. Repeater is an excellent tool, and it'll be there for you in your future endeavors. And it'll be there for us throughout all of these lessons. So we have ID. What if I tacked on ID and who am I? Uh-oh. Burpsuite knows what's about to happen. Burpsuite knows what's about to happen before it even happens. That ID, that ampersand, it's looking to see that ampersand, this is going to, it's viewing this like a value, like a parameter, like the who am I parameter. That doesn't make sense. It's expecting param equals value. See? The blue and the green pop up. So when we send this along, our command injection of an ampersand might not work there. Let's send and who am I, and then a backtick. Doesn't work. It doesn't work. That's unfortunate. But we see there how sometimes if this was an input field, what if this had been post data? Well, even then, if we right click and change request method and we had rev equal to ID, we still have that more visible. That really helps with visibility. And who am I is equal to what? No, that's not going to work. That ampersand is a very sensitive character in web attacks and a very sensitive character to consider when doing command injection. However, let me be perfectly clear. If there is an input parameter that allows and does not supply proper sanitization, then in effect, you can bypass that and the and parameter will work just like this. ID, and when done executing ID, execute, who am I? So root and UID equals 0. Or we can see ID and who am I? That would be the more proper way. But you can use an and or an and. Either way, these are things that you should be playing with when you think that you're onto a command injection type finding. And with that, let's go ahead and remove this. Let's change the request method back. We'll remove all of this garbage. We'll set that there, $, send it along. We have our www data, and we've already proven that we could set this to a bind server, nc-nlvp on 9090-execute bin bash. Now there is a difference. This will not work. This will not work. We need to add encoding here because we're working in Burpsuite. So when we have spaces, make sure you add that plus sign for URL encoding, plus the parameter -e, plus bin bash. And this would work successfully. So let's try it again on port 9997, and we'll send this along. This should spin. That's cool. We'll up arrow to netcat netverbose at the target IP on 9997. There it is. Port is opened, and we have a shell. Boom. That's TWiki exploited without having to throw the Metasploit payload at the target machine. We could have done something entirely different. In fact, I want to conclude this entire lesson with something else. Let's say we only had one Metasploit card on our exam. Well, this would be something to talk with the exam proctors and the exam community with regarding the rules. But regardless of examination, I really do want to show you this. Instead of targeting, this is good pen testing practice, right? If we're going to analyze a payload, and we always want to analyze those payloads, let's search for TWiki again. We'll use for, and the only difference here, we're going to show payloads, you know the drill. We're doing debugging here. We're going to say payload CMD, not Unix reverse, CMD Unix generic. And we'll type set payload, paste that in, type options, set CMD, notice it's blank, set CMD equal to ID, except this time, instead of setting our host, the target host, to 192.168.1.23, the much more professional thing to do when analyzing payloads is to think local and set the remote host to your machine, your loopback adapter. So set it to that. Set it to 127.0.0.1. And if you're analyzing the payload because you're unsure, you're uncertain, maybe you're testing a service that's running only locally on your machine, you can set that to the loopback adapter. Now hit run. And if we let this go, it's going to say unknown error. That's fine. Whoa, payload. No, Metasploitable. It didn't like that. It really didn't like that. But let's try this again. Set verbose maybe to true. Set our hosts to localhost. We could call it that. And type run. And maybe that's not working. Maybe it doesn't want to hit the local host. Usually it will. Maybe this particular payload is finicky. Well, what if we set the target to ourself? Set our host to 192.168.1.not23, but 233. And this time type run. There should be in here, usually, well, it's not working. Maybe that's because it doesn't have anything to connect to. What if we type netcat and we imitate a web server on port 80, NLVP on 80. And now we set our host back to 127.0.0.1. Let's clear this, type options. Notice the R port is 80. It should connect to our loopback adapter on port 80. Let's type run. And there it is. Would you look at that? That's another way of debugging payloads that are web-oriented, or even just payloads in general that require a report. You can use Netcat to listen on that respective port that it would be targeting. I don't care what port it's targeting. You can just use Netcat to spoof that and capture that traffic. Oops, drag and drop operation. But nonetheless, you can capture that traffic. And we're going to conclude with that final little lesson. Of course, then you would then take that and you would decode it and debug it and work with it, and so on and so forth. Guys, my name is Siren here with Startup.Security. I hope you enjoyed this lesson, and I will catch you in the next one.